Hello viewers, welcome to Senior College Mathematics. Topic of discussion is sequence and series. Lesson 1, Introduction, Definition and other concepts. A sequence is the arrangement of numbers in array. An array means the arrangement of numbers in an ascending or descending order of magnitude. When numbers are arranged following ascending or descending order, the numbers are said to be in sequential order. Another term used interchangeably with sequence is progression. For examples, number 1, you have this sequence 1, 2, 3, 4, 5, 6, and so on. This sequence follows ascending order. Example 2, you have 3, 6, 9, 12, 15. Ascending order also. Number 3, 1, 2, 4, 8, 16. This is also ascending order. You have number 4, 16, 8, 4, 2. This sequence follows descending order. In sequence, each number is called a term, and the terms tend to follow an order or a pattern. For example, let us get the pattern for this sequence 1, 2, 3, 4, 5, 6. If you observe very well, to get the second term, you need to add 1 to the first term. To get the third term, you need to add 1 to the second term, and so on. The pattern here is addition of 1 to the previous term to get the next term. Example 6, we have this sequence and the pattern is needed. 16 is the first term, 8 second term, 4 third term, 2 fourth term. If you observe very well, if you divide the first term by 2, you have the second term. If you divide the second term by 2, you have the third term. If you divide the third term by 2, you have the fourth term. Therefore, the pattern here is division of the previous term by 2 to get the next term. Next, we shall discuss the nth term denoted by T sub n of a sequence. This term is like a formula that helps you to generate other terms in the given sequence. Consider the sequences in example 1 to 4 above. You have the first example. We want to get the nth term of the sequence. When you are doing that, you always think along the first term. The first term here is 1. The first term is always there. To get the second term, you need to add 1 to the first term to get the second term. To get the third term, you need to add 2 to the third term, and so on. So the first term is there all through. You have it in the nth term. Now share the pattern. If here is 0, you have 1, you have 2, and 3. That means when n is equal to 0, you have the first term. When n is equal to 2, when n is equal to 1, you have the second term. When n is equal to 2, you have the third term, and so on. So this is the nth term for this sequence. So for this sequence, n is 0 for you to get the first term, while in some other sequences, n can be 1 for you to get the first term. You have the second example. Want to get the nth term of this sequence. The first term is 3. Remember, you always think along the first term. To get the second term, you have to add 3 to the first term to get 6. To get the third term, 9, you have to add 6 to the first term to get 9. That means the first term is there all through. But observe 3 and 6. We cannot get a pattern from here. So we can express 3 plus 3 as 3 times 2. You can express this as 3 times 3. It therefore means this one becomes 3 times 1. So the nth term becomes 3n. So that when n is equal to 1, you have the first term. When n equal to 2, you have the second term, 3 times 2. When n equal to 3, you have the third term. And when n is equal to 5, you have the fifth term. That is 3 times 5 equal to 15. Example 3, we have this sequence. The nth term is needed. All right. The first term is equal to 1. But if you observe from the second term to this term, 2 is common. You can express 4 as base 2 power 2. You can express 8 and 16 in the same format. That means base 2 is common. Then, can you express 1 as base 2 also? Yes. That is 2 power 0. We give you 1. The second term is 2. It becomes 2 power 1. The third term is 4. That is 2 power 2. The next term is 8, written as 2 power 3. You can see that the base 2 is common all through, and the powers 0, 1, 2, 3, and so on. So we can write the nth term of the sequence as t sub n equal to 2 power n. So that when n is 0, you have the first term. When n is 1, you have the second term, and so on. Number 4, you have this sequence. The first term is 16. If we are to think along the first term, if you divide the first term by 2, you have the second term. Since the first term needs to be there, we have it as 16 times 1 over 2, which also means 16 over 2. To get this term, you have to multiply by 1 over 2 again. And to get this term, you multiply by 1 over 2 again. In other words, you are dividing this term by 4 in order to get this term. And you can express 16 over 4 as 16 times 1 over 4. In order to have this term to be common, you can write 1 over 4 as 1 over 2 times 1 over 2. With this, we get the nth term as 16 times 1 over 2 in bracket to the power of n minus 1. Why is the power like this? That means here also we have 16 times 1 over 2. And what we need is 16, the first term. In order to remove this, the power needs to be 0. So if you have n minus 1, when n is equal to 1, 1 minus 1 is 0. So for this sequence, the first term is obtained when n is equal to 1. When n is 2, here becomes 2 minus 1, that is 1. So you have 16 times 1 over 2 and so on. Examples, you have the instruction, write down A, the rule, B, the next 3 terms of each of the following sequences. Number 7, you have 2, 6, 14, 30, and so on. You have to think of the rule that can generate the second term, third, and fourth using the first term. The second term is 6. The first term is 2. You have to think of the rule that can generate the second term, the third, and fourth. From here, if you add 1 to the first term, you have 3. Multiply it by 2, you have 6. Then, to get this term, if you add 1 to the second term, multiply by 2, you have 14. And here, if you add 1 to 14 multiplied by 2, you have 30. The rule is add 1 and multiply by 2. So, for the next term, you add 1 to 30, that is 31. Multiply by 2, you have 62. The next terms becomes 126 and 254. Example 8, you have the sequence. The first term is 1600, the second term is 800, the third term is 400, and so on. If you observe very well, if you divide the first term by 2, you have the second term. If you divide the second term by 2, you have the third term, and so on. So the rule is divide by 2. B part, the next 3 terms are 200. You divide 400 by 2, you have 200. You divide 200 by 2, you have 150 as the next 3 terms, following the rule of dividing by 2. Find the nth term of the following sequences. Example 9, you have 7, 12, 17, 22. If you observe very well, the pattern or the rule is to add 5. If you add 5 to 7, you have 12. If you add 5, you have 17, and so on. The rule is add 5. The question is, which number will you add 5 to in order to have the first term 7? That is 2. So the first term 7 becomes 5 plus 2. Second term is 12, that is 7 plus 5. Third term becomes 7 plus 10. You know 10 is a multiple of 5. Now let's come here. Because of this, the arrangement has changed. So now we are seeing 5 as the first term, the way it is. With this pattern, you cannot get the nth term. So let's shift our attention to 5 plus 2. Let's work with 5 plus 2 as the first term and generate the other terms with it. So here, if you multiply 5 by 2 and you add 2, you have 12. If you multiply 5 by 3 and you add 2, you have 17. If you multiply 5 by 4 and you add 2, you have 22. So for the first term, it becomes 5 times 2 plus 2. The third term, 5 times 3 plus 2, and so on. You will now observe that there is 5, 5, 5, 5. So this 5 means 5 times 1. See that? 5 times 1, 5 times 2, 5 times 3. So this plus 2 will be there all through as plus 2. Then from this and others, you have 5n. So that when n is 1, you have 5 times 1 plus 2 is 7. When n is 2, you have 5 times 2 plus 2, that is 12, and so on. This becomes the nth term of that sequence. Example 10, you have the sequence 70, 65, 60, and 55. Of course, there are other terms. If you observe very well, the rule is subtract 5. The first term is 70. So which term are you going to subtract 5 from in order to have 70? That must be 75 minus 5. So here we are dealing with 75, which needs to be there all through. The same way 5 and plus 2 helped us here. So for us to get the second term now, you have to subtract 10 from 75 to get 65 and so on. Now we have settled this case. Now look at 5, look at 10, 15 and 20. 10, 15, 20, they are multiples of 5. For us to get the pattern, you can express 5 as 5 times 1. You can express 10 as 5 times 2. You can express 15 as 5 times 3, and so on. So you have 1, 2, 3, 4. There is always an order that n can assume. So if you replace this order 1, 2, 3, 4 with n, the nth term becomes 75 minus 5n. This nth term can help us to generate as many terms as possible without stress. Next, we shall discuss the types of sequence or progression. Basically, there are 3 types of sequence. Number 1, arithmetic progression denoted by AP. Number 2, geometric progression denoted by GP. Number 3, harmonic progression denoted by HP. At this level, we shall discuss the first 2 types of sequence. or progression. Complete details in subsequent lessons. End of lesson 1. Thanks for following to the end. Don't forget, watch out for more from the voice of Peter Kos. If you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the one that can save you, and that is the Lord Jesus Christ, and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations, live righteously and be prepared, because on the last day, some will be taken and some will be left. Be good to yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.